So here I have 6. So this is hexane to start with. And then which end do you think I should start numbering from? From the right or from the left?
Left.
Look, there's nothing over here on this end of the molecule, is there? Maybe we should start numbering from over here.
Yes.
1, 2, 3, 4, 5, 6. So we have, let's write it up here first. We have 3, 4 dichloro. And we also have 2, 3 dimethyl. Does everybody see why it's 3, 4 dichloro and 2, 3 dimethyl? You don't see how I got methyl? These are CH3 groups, right? If I put H's on them, I left the H's off.
Yeah.
These are CH3 groups right here, so it's methyl. Okay? So when I write the name for this, it is 3, 4 dash dichloro dash 2, 3 dash dimethyl hexane.
How do you know it's dichloro or dimethyl?
Because there's 2 chlorines, so it's dichloro. And there's 2 methyl groups, so it's dimethyl. If there were 3, it would be trichloro or trimethyl, right?
So you don't consider carbon number 6 a substituent?
No, because it's if you call that a methyl group, look, that just makes the chain longer. That's what I said. You can't put an alkyl group, a methyl, ethyl, propyl group on the last carbon, because it just makes the chain longer. Because I could have drawn this with that carbon sticking out over here. It's the same thing.
He just does.
I could have, instead of drawing my line straight through, like I could have drawn my line like that. There's other ways to draw it. These 2 carbons are equivalent, basically. Yeah. I drew it up like that because I know that there's one in the homework drawn just like this that's going to mess you up if you're not real careful with how to select the longest chain. Okay? Be careful when you check the longest chain. Fair enough? Does everybody understand how we got the numbers? The numbers don't tell you how many, they tell you where they're located. And the die tells you how many. Okay? Fair enough?
And so you decided to count from the left to the right.
If I'd have counted from the right to the left, so if I count the other way, if I go 1, 2, 3, 4, 5, 6, like that, then my chloros would still be 3, 4, but my methyls would be what? 4, 5. Who wins? The top one wins, right? These are the same, but 2, 3 is less than 4, 5, isn't it?
Yeah.
So 2, 3 wins.
Where do you get the 4 from? On the guide 4.
Where's the 4 from?
Yeah.
3, 4. There's a chlorine on the 4th carbon here. There's a chlorine on the 3rd carbon, and there's a chlorine on the 4th carbon. That was rough, huh? You can do this one, you're going to be able to do the homework. I promise. Okay? Now, when you have cycloalkanes and you have substituents on them, if you only have one substituent, it's pretty easy. You don't need to use numbers. This is just called ethyl hexane. You still name it as ethyl cyclohexane, sorry. It's cyclohexane, right? And it's got some stuff sticking off of it. That stuff sticking off is an ethyl group, 2 carbon. So this is ethyl cyclohexane. Okay? Now this slide I do not like. There's something wrong with this slide. Anybody want to tell me what's wrong with this slide?
It has the one.
It has a 1-methyl on it, doesn't it? Let's draw this compound. Let's draw it. Heptane is how many carbons?
7.
1 chloro, 1 2-dimethyl. What's wrong here? By putting a carbon on the 1 here, by putting a methyl, what's happened? I can now draw 8 carbons in a row. You can never have a methyl or ethyl or propyl on the 1 carbon.
So is that not?
This slide is wrong. Somebody messed it up. Okay? The other stuff is good. Dimethyl would mean 2 methyl groups, right? 1 chloro means you have a chlorine on the 1 carbon, right? But when you draw it out, it doesn't work. So you guys are going to draw this formula. You guys draw this formula real quick, and then we'll draw it together on the board. I think going from the name to the structure is way easier than getting the name from the structure. You don't think so? Because you have the name, it tells you everything about it.
Does it matter which side you put them on?
No, as long as no, you mean top or bottom? No. Because why? Remember we said that bonds are free to rotate, this carbon bond, so it doesn't matter. We ready? What's the root name? How many carbons in butane?
4.
4 carbons? What else do we have to do?
There's a chloro on the first one.
There's a 1 chloro,
And then the third one is
third one is bromine. If I want to finish it, I should put the hydrogen on it, right? So when you have to draw them in mastering, you have to put the hydrogen on it, okay?
They want the dashes too?
Yeah, because the dash means what?
they're
Bond.
connected.
Bond. Now this is the expanded formula, okay? This is the expanded structural formula. If I want to write the condensed, which it asks for, bless you,
Thank you.
condensed would mean what? CH2Cl, CH2, CHBr, CH3. Okay?
So condensed means write that out?
Yeah, condensed means to draw it like this. This is the expanded structural formula, right? This shows all the bonds. And then this just takes each one of the carbons and compresses it down like this. Okay? Just like we did before. Right? Remember before, it would have looked like that, right? What have we done? We've replaced one hydrogen here with the chlorine, and we replace the hydrogen here with the bromine, right? Okay, so that's all we've done. These should look very similar.
So how do you know
Yeah.
replacement of the bromine is where it is and not at the bond next to it to the left, the next one over.
Because it says 3-bromo. If I call this the 1 carbon, where I have chlorine, 2, 3, 4. Bromine is on the 3. That's what it tells me right here.
Okay, but what I'm asking is, how do you know the numbers 1 through 4 aren't in the opposite sequence so that?
Because I started with the 1 carbon, there's a chlorine on the 1 carbon. And so when I put a chlorine on this carbon, because of this name, that made this the 1 carbon. I couldn't start numbering from this side because I don't have a chlorine over here. It told me that this was 1 chloro, so it had to be there. And that's the side I'm going to number from. Okay? Fair enough?
No.
No? Where do you want to put it
Well,
at?
I'm confused. How do you know where the, like, I understand you got the chlorine in the first
Carbon.
carbon, but how come you decided that's the first carbon and not the one all the way to the right?
It doesn't matter. I could have put the chlorine down here, you're right. And then the bromine would have been here. That's the same molecule.
Okay.
It's the same. Yep. If I'd have put the chlorine down here, then the bromine would have had to move over 1.
Right.
Right. You're exactly right.
Okay.
But once I put the chlorine here, then the bromine has to be here, right? Fair enough? So if you like to number your stuff from right to left, I don't know who does that. We don't live
Well,
in
and you're just looking at the least number
And then,
to
well,
start with your element like that?
yes. If I have anything on the 1, I'm going to do that first because it's going to tell me which end of the molecule to work from.
Okay, so if it was 2-chlorobutane,
I could have put
you
it
started
here.
at the 2, okay.
Yeah. Or I could have put it here, either one, and then that would have told me how to make the bromine then, right?
Yeah,
It would have had to go to the one next to it,
okay,
right? Either one works.
all right.
Can you name each of these 2? And then we'll call it quits. I'll work on this for a second. Those are methyl groups, right? At the point, you always assume that there's a carbon at the point, right? Unless there's something else there. Like this one has Cl, so you know it's a chloro. These, you have to assume that there are carbons there, right? We ready? They are both what? They're both pentane, aren't they? But this one has this on it. So what is this? 2-chloro. Why is it 2?
It's not. How do you know which way to count?
Because if I'd have counted from this end, 1, 2, 3, 4, it would have been 4.
You want the lower.
I want the lowest number.
Lowest number.
Lowest number possible, yep. What we said earlier, lowest number wins. And this one, this would be what? 2, 3 dimethyl. Why? 1, 2, 3, 4, 5. 2, 3 is better than 3, 4.
Okay, wait a second. Are you counting from this side, like 1, 2, 3?
I counted from the left. 1, 2, 3,
No, I
4,
meant
5.
A. A. Are you going like? in
I from
order?
A, I counted from the right hand side.
Oh, so that's
Because if I'd have counted from the left, it would have been 4.
okay, you just go where the lesson number goes.
2 is less than 4, right? There's plenty of practice on mastering for you.
Oh,
Aren't you excited about that?
no.
And you can go home and read your shampoo bottle now
I wish I would
and
have.
sort of understand what it's talking about a little bit.
So how do you know those,
All right, well, hold on. We're not finished,
how do
yes?
you know those carbons on number B are considered a methyl and not an ethyl or propyl?
Because there's only one line. If it was an ethyl group, it would have looked like that. 1, 2 carbons, right? Actually, you couldn't have an ethyl group there. You'd have to have it up here, like that. But there's just one straight line. An ethyl group would be bent like that.
Oh, okay.
Carbon here, carbon there, right?
Why would you go and have it on the bottom one?
Right here, why couldn't I have it here? Because then that makes my chain a 6 instead of a 5. Right? 1, 2, 3, 4, 5, 6. If I had an F over here.